In this tutorial video, we shall be discussing on SARIMA models for time series. The SARIMA models are models that are used for forecasting in time series. What are SARIMA models? SARIMA means seasonal autoregressive integrated moving average model. So that's the meaning of SARIMA. Unlike Arima, we just add the seasonal part of it to make it SARIMA. So this SARIMA is written as P, D, Q, small letters, then P, V, Q, capital letters with the seasonality. Now, the next thing to do is to first write out the model, then define each parameter so that you know how to use it to compute the SARIMA model. Now, the first thing to do is to write out the model. The model for SARIMA is written as 5B P, 5, this is the seasonal part, PS, B, P multiplied by S. Then we have the differencing part. We also have the seasonal part, the differencing part with seasonality. We have the non-seasonal part, the differencing part that is the non-seasonal part. Then we have X2. We also have the moving average part, which is Q, B, Q. Then theta Q comma S, B, Q multiplied by S, then ET. ET. So this is simply the SARIMA model. This is how it is written. So whenever a question is given like this, that question will appear in this form. When it appears on this form, then you know you have completed the SARIMA model. Now, we'll define each of these parameters. File, we say here, for more on this topic, you need to subscribe to this channel. Here, file P, BP is the autoregressive parameter. Of course, this one is the one that has non-seasonality, or you say it's a non-seasonal part. We also have file that has the seasonal part, P multiplied by S, is the autoregressive parameter with seasonal part. We also have this with differencing. This is called the differencing seasonal part. Now, we also have this. It's also differencing, but the non-seasonal part. So, we have this. We also define what they are to show you how it is being used. Differencing non-seasonal part. We have XT. This XT is the time series okay, we say time series value. You can call it the time series values. We call it the time series values. Now, we have the moving average part, which is this. So we have theta. For more information or for more on this topic, you need to subscribe to this channel. So we have the moving average part. So this is the moving average parameter. Moving average parameter, non-seasonal. Non-seasonal part. Then we also have the moving multiplied by S. We also have the seasonal part for the moving average parameter. So if the moving average parameter seasonal part, then we have ET. ET is the error term. Error term, or better still, you can call it the white noise process. Then we have S. This S. This S means seasonality. So it is seasonality of the model. So we have succeeded in defining all of these parameters. And I'll also show you how they are being used. How they are being used when computing. How they are being used when computing. So for you to do that, we have to delete this part of the board to now show you how they are being used. So for more on this topic, you need to subscribe to this channel. So since we have this, we take it gradually. We have to delete this part of the board. For more on this topic, you need to subscribe to this channel. So we show how they are being used. Now, the 5P BP can be computed as 1 minus phi 1 B1 minus phi 2 B2. It continues that way to give you 5P BP. So this is how this part is being computed. Now, the seasonal part of it is computed as 5P, X B P multiplied by S is computed as 1 minus 1 S B 1 multiplied by S minus 2 S B 2 multiplied by S, which is 2S. It goes that way to give us 5 P, S B P multiplied by S. So this is how the seasonal part can be computed. This is how the seasonal part can be computed. Now, we have the differencing part, which is already stated here. So the differencing part, which is this, can be computed as 1 minus d, then d multiplied by s. That is ds. So this is how this part can be computed. Now, we also have the non-seasonal part for the differential. The non-seasonal part for the differential can be computed as 1 minus d raised to the power of d. We have the moving average. The moving average part. How is it computed? The moving average part, we have theta q d q to be equal to 1 plus theta 1 b plus theta 2 b2 plus, it continues that way, theta q dq. Theta q bit q. So that is how it can be computed. We also have the seasonal part of it. The seasonal part of it. The seasonal part of it, that is theta q s, then d q multiplied by s to be equal to 1 plus theta 1s, 1 comma s, b 1 multiplied by s plus theta 2 comma s, b 2 multiplied by s plus, it continues that way, plus theta q comma s, then b q multiplied by s. So that is how it is being computed. That is how that part is being computed. So this is how we can use the SARIMA model. This is how the SARIMA model can be computed. For more on this topic, you need to subscribe to this channel. So with this, we can take just one question to see how we better understand what we are saying. We can take one question to add to this. We can take one question. So for me to do that, we'll delete this part of the board. For more on this topic, you need to subscribe to this channel. So we can start with this question. Compute SARIMA 11111 with seasonality 2. So we can compute this. How do we compute this? From what we have explained before now, we can compute this. We also delete this part of the board. For more on this topic, please subscribe to this channel. Now we can compute this. The first thing to do is to write the model, the SARIMA model, and the model is given as 5P BP 5P comma S B P comma S. We have our differencing part, the seasonality. We have our differencing part. We have X2. We have the moving average part. Then we have 80. So whatever we are doing, we complete it to this form. Now, the first part, which is pi dp p, which is p dq, that means p d and q, then capital letter p, capital letter d, and capital letter q. Now, for the autoregressive part, we have it of order p, which is 1, just 1. So we have 1 minus pi 1 pi 1 d1. That is it. For the differencing part, okay, we have here, for the seasonal part of it, we have pi, the seasonal part, b, es, the for the seasonal part, we have the seasonal part, we have it as 1. So we have 1 minus pi 1. We have our seasonality to the 2, 1 comma 2b, just 1. So we have 1 multiplied by s, that means 1 multiplied by 2, which is 1 multiplied by 2, which is 1 minus pi 1 comma 2, then b squared. Also, we have our differencing, the one with seasonality, which is 1 minus d, then d multiplied by s, which is 1 minus d. We have d to be 1, the order is 1, multiplied by s, which is 2. So we have it as 1 multiplied by 2, which is 1 minus d raised to the power of 2. We also have our differencing here. Our differencing with non-seasonality. That means this part, which is 1 minus b raised to the power of b, which is 1 minus b raised to the power of b. b is 1, just 1. The non-seasonal part is 1. So it doesn't mean that we have just 1 minus b. Then we have xt, which is our time series value. We now have the moving average part. The moving average part, which is q, the one with non-seasonality, is equal to, we have it as 1, because we have all of them here as 1. So the moving average part, which is q, is this. We have it as 1. So it will now be 1 plus just 5, 1 multiplied by s, 1 comma s, that means 1 comma 2, then z raised to the power of, we now have 1 multiplied by 2. 2 is valid, so we have 2 here. That is 1 multiplied by 2, 1 multiplied by 2. So we can write it to be 1 plus theta 1 comma 2 b raised to the power of 2. We also have the moving average with seasonality. So we have theta qs b q multiplied by s, which is equal to 1 plus, sorry, sorry, this part is the part with non-seasonality. So the part with non-seasonality is just theta 1b, which is equal to 1 plus theta 1b, b raised to the power of 1. Now, the one with seasonality is theta 1 comma s is 2. S is 2, which is our seasonality. Now, we have b 1 multiplied by s, which is 2, which is written as 1 plus theta 1 comma 2 b squared. So the next thing to do is to now write out our SARIMA model. How do we write out our SARIMA model? We will write our model to be in this form. We write the model to be in this form. Now, the first part we have is this. The second part, the third part, the fourth part, that means the autoregressive part with non-seasonality is 1 minus this. So writing our model, writing our model, we have 1 minus 5 1b. That is for the autoregressive non-seasonal part. Then the autoregressive seasonal part is this. So we have 1 minus 5, 1 comma 2, b squared. Now, we also have our depressing, the seasonal part. We have it as 1 minus d squared, 1 as 1 minus d squared. We also have our depressing part, non-seasonal. That means this part. We have it as just 1 minus b. Then we put our xt. We put our xt, which I have done there. Now we move over to our moving average part. Our moving average part will now be equal to the first part here will be our moving average part. We got 1 plus, we have this as equal to plus theta 1b, theta 1b multiplied by this. So we have 1 plus theta 1 comma 2, then b raised to the power of 2. Then we also put our ET. We put our ET. So if you have to compute SARIMA, this is simply how to compute the SARIMA model for a given time series. Like we said initially, that the SARIMA model is used for forecasting. Once we go through all these processes, then we'll be able to compute any equation that is given to us on SARIMA model. So for more on this topic, you need to subscribe to this channel.